Hi, in this video we're going to discuss natural logarithms. Before we do so, it is important to distinguish the different forms of logarithms um, so that we can better understand logarithmic operations. As we discussed in the previous videos, we have a general form in which we have the logarithm of some number n to the base a equals some number x, and this corresponds to n equals a to the powered x. We also have a common logarithm, which essentially is the same thing as the general form. Instead of a, the base is 10. However, it is common in math to not write the base 10, and we just leave it logarithm of n equals x, and we automatically know that this means n equals 10 to the power of x. So usually we don't have our base 10 written. It is not required in mathematical notation. So that's why it's referred to as the common log. However, in for today's topic, we're going to discuss natural logarithms. It follows the same form of the general logarithm. However, the notation is different. Instead of log, we have ln, or natural logarithm, and essentially the ln of some number n equals x corresponds to n equals e to the powered x. And for those of you who might not know this, e is a mathematical constant, also referred to as Euler's number. So essentially, natural logarithm is, let's say, log of some number n to the base e equals x. And again, if you follow the general form that we have on the screen, this would mean n equals e to the powered x. The notation is different. We don't write the e as the base, and we, instead of having log or log, we use the terminology ln. The rules that we discussed earlier about logarithms still hold true for natural logarithms as well. I will put the link in the description for the earlier videos that we done on logarithmic properties. For those of you who haven't watched that, I highly recommend you to do so, and also go through the practice questions that we did to better your understanding of logarithms. However, I wanted to point out two or three additional properties of natural logarithms that we did not discuss in our earlier video. So properties of natural logarithms. First thing, again, all the conditions in which we said if there's two numbers being multiplied in a logarithm, it could be translated into an addition. Same thing with division. Same thing moving the power or exponent before the log. All of that holds true. One thing that I wanted to add is that, let's say we have the mathematical constant e powered to natural logarithm of x. If this is simplified, it would result in x. So whenever you see that, you could automatically simplify this, and it would result to x. That's what number one. The next property I want to discuss is that if we have ln of e to the powered x, the result would be x as well. Now, this is important. I emphasize that this e is not the base. It is the natural logarithm of the number e itself. And again, following general rules of logarithms, we said that we could move, essentially, to better illustrate this, we could move this x exponent here outside of the logarithm. So it would be x ln of e, but we already know ln of e is already base to the base e. And one of the properties of logarithm that we again discussed in our first video is that if we have the logarithm of some number b to the base of that same number, the result would be 1. Therefore, we could further simplify this expression as x multiplied by 1, which would be x. This is also an important property which will help us in simplifying natural logarithm expressions. And lastly, I wanted to say, if we have a natural logarithm of some number x equals the natural logarithm of some number y, this means that x and y is equal to one another. These are important properties of natural logarithms that can really help when we're simplifying mathematical expressions and or even expanding. So let's do some examples on natural logarithm. Let's say we have the natural logarithm of 4x minus 3 equals some number, I don't know, 8. And we know that, again, from what we discussed, we know that we have a base e here. So to rewrite this whole expression, we could say 4x minus 3 equals e to the powered 8. Now, this is a constant number. It's not a variable. For those of you who are not too familiar with e, again, it's a mathematical constant. It is not a variable. So we could keep that on the right side and have our variable for x on the left side and move the 3 to the right side as well. So it will be e to the powered 8 plus 3. And we could further simplify this by dividing. Oh, sorry, what happened there? E to the powered 8 plus 3 divided by 4. And we could plug in this into our calculator and we'll get some value, but this is a constant number. We can even do other ways of, there are other ways to utilize natural logarithms. For instance, if we have an equation such as 2x equals 3x plus 1, let's say. Over here, we could basically put both sides to in a natural logarithm. If we take the natural logarithm of both sides, that would be fine. Again, as we said here, the equation tells us that 2x equals 3x plus 1, therefore the natural logarithm of both of these sides is the same. So we could rewrite this as the natural logarithm of 2x equals the natural logarithm of 3x plus 1. Now, we know that we can move the exponents outside of the logarithm, so we could say x multiplied natural logarithm of 2 equals x plus 1 multiplied by natural logarithm of 3. Now, this number and this number, again, they're constants. E is a constant, 3 is a constant, the natural logarithm is a constant. So all we have to figure out is now the x's. And if we move the x's to one side of the equation, we could rewrite this as x ln of 2 minus x ln of 3 equals ln of 3, because we multiply ln of 3 with x by x and by 1. And again, we can further simplify this and rewrite it as x multiplied by, we essentially factor out x ln of 2 minus ln of 3 equals ln of 3. And now, pretty much, we have our answer. Ln of natural logarithm of 3 equals the natural logarithm of 2 minus the natural logarithm of 3. And again, you could plug in these numbers into your calculator and find the value for x. That would be all for in terms of the examples. Feel free to leave comments down below, and if you have any questions or if you have examples in mind that you would like me to solve and post on my channel, feel free to do so. Stay tuned for future videos.